Good morning students. My name is Nandita, mohant, Assistant Professor of Civil Engineering Department. Today I am going to discuss about introduction of geotechnical engineering. So before going to start definition of geotechnical engineering, I would like to first discuss about why this is important for civil engineering. So suppose we design a very good structure, very economic structure, and it may be lightweight or it may be low weight. Our structure is registered by soil only, and load of entire structure is registered by the soil. If the soil present below the structure is not very good, or it may be very weak, then this kind of failure may occur. Here also we can see that because of improper compaction, this kind of failure in roadways. Okay, so to avoid this kind of failure, we should know proper properties of soil, bearing capacity of soil, shear strength of soil, everything we should know before going to construct a structure. So here we can see after improved soil bearing capacity, soil can bear here without compaction only 5 kg, and after compaction it can bear 10 kg. And here we can see with proper compaction decreased settlement. Okay, so here we can see cracks formed, and here soil is here structure is safe. Okay, so increased soil stability. So after proper compaction, here we can see our structure is safe, and without compaction structure is tilt. Okay, so proper compaction also helps to reduce water seepage. Here we can see without compaction more seepage, and without compaction more seepage occurs, and with compaction less seepage. Okay, so next is definition of geotechnical engineering. Definition of geotechnical engineering. So geotechnical engineering is the study of behavior of soil under influence of loading forces and soil water interactions. So this knowledge is applied to design of foundations, retaining walls, and earth dams. So here geotechnical engineering is the study and behavior of soil under various type of loading forces, and how water in soil affects that behavior, and how water in soil affects that behavior. So this knowledge is applied to design foundation, retaining walls, and earth dams. This is all about definition of geotechnical engineering. Next is introduction to soil. As per civil engineering, soil may be defined as an uncemented gathering of mineral particles which are produced by disintegration of rocks. So disintegration means weathering. So weathering is two types. First is physical weathering, and second is chemical weathering. So because of physical weathering, coarse grained soil are formed. What are the coarse grained soil? All coarse grained soil are formed, like sand, gravel. All these are formed by by coarse grained soil. All coarse grained soil, CGS are formed by physical weathering. Okay, so second is chemical weathering. So second is chemical weathering. Because of chemical weathering, clay are formed. Okay, because of chemical weathering, clay formed. Clay formed. Next is scope of geotechnical engineering. The geotechnical engineering has very large application in construction of various civil engineering works. The physical properties of soil mechanics is particularly helpful in following problems of civil engineering. Okay, so physical properties of soil mechanics is particularly helpful to following problems of civil engineering. Okay, so these are basically designed after getting proper knowledge of geotechnical engineering. So first is foundation design and construction, retaining structure, underground structure, stability of slopes, pavement design of earth dams. Okay, so next is foundation. Foundation is an important element of all civil engineering structures. Okay, so every structure like building, bridge, dam, highway, tunnel, canal is founded in or on surface of the earth. Foundations are transmitting load of structure to the soil safely. So here we can see the lower part of the structure is known as foundations. Okay, so here we can see these are foundations. These are the foundations. So the entire structure weight of entire load of the structure is registered by soil, and the load of the structure is transmitted to soil by foundation. Okay, by foundation. So what is the work of foundation? Foundation transmit the load to the soil safely. Okay. Similarly, suitability of various type of foundation, shallow foundation, pile foundation, etc. depends upon soil strata, load, and groundwater conditions. So based on the soil type and load of the structure, we will design foundation. Okay, this is shallow foundation and this is deep foundation. Okay, so next is retaining structure. The structure which retains large mass of earth on its side is called retaining structure. Okay, so here we can see the structure. This structure is known as retaining structure. This is retaining wall. Okay, so here soil is supported by this retaining structure. Okay, so soil is supported by this retaining structure. So theory of earth pressure given by geotechnical engineering is required to design such retaining structure. Okay, so to design this kind of retaining structure, we should know theory of earth pressure. Okay, so we should have deep knowledge of earth pressure. So before going to construct this kind of retaining wall, we should have proper knowledge of geotechnical engineering. So next is groundwater structures. So groundwater structures, it consists tunnels, pipelines, underground buildings are subjected to various forces exerted by soil mass. A knowledge of soil structure interaction is essential to design properly to such structures subjected to soil loadings. Okay, so here we can see tunnels. This is tunnels. This tunnel is totally exerted by soil. Okay, this is pipeline. This is pipeline. So these are exerted by soil. So here we can see how deep knowledge of geotechnical engineering we should have. After that, we should design a tunnel and pipeline. Okay, next is stability of slope. When soil surface of structure is not horizontal, such as in case of highway embankment or irrigation canal, the component of gravity tire to move the soil downward. Okay, so a complete knowledge of shear strength and related properties of soil is necessary to design the slope of embankment or excavation or cutting. Okay, so here we can see stability. Okay, this is slope. So this is slope. Okay, so to get proper stability, we should have proper knowledge of geotechnical engineering. Okay, we should have proper design of geotechnical engineering, like shear strength, properties of soil. Okay, and how to design of slope, embankment. Otherwise this slope, the soil will going to move downward. So embankment going to fail, and this structure. Okay, so the roadway going to collapse. Okay, so before going to construct, we should have proper knowledge of geotechnical engineering. Next is pavement design. A pavement can either be flexible or rigid. Its performance depends upon the subsoil on which it rests. Okay, so here we can see this is flexible pavement and this is rigid pavement. Okay, so we will decide after what is the subsoil behaves. Okay, so if our subsoil is very good and shear strength is very good, then we will go for flexible pavement. If our soil is very weak, then we will go for rigid pavement. Okay, so the thickness of pavement and its component parts depends upon certain properties of subgrade of soil. Okay, also the thickness of pavement also we decide the properties of subgrade of soil. Okay, the soil properties such as strength, stability, and very much helpful to constructing a pavement or poor soil by stabilizing them. Otherwise, if we have a very weak soil, we should stabilize them before going to construct pavement design. Before going to design a pavement. Next is design of earth dam. The construction of earth dam requires a very thorough knowledge of the soil mechanics. Okay, to design earth dams we should have deep knowledge of soil mechanics. because it requires a determination of various physical properties of soil such as density, plasticity, characteristics, permeability, compaction. Okay, so these are the basic things we should have knowledge. Okay, we should have thorough knowledge. After that we can design a earth dam, because large in earthen dam, storage is huge. Okay, storage is huge, and volume of storage of water is storage of huge volume of water, and its failure may cause widespread disaster. Okay, so we should have proper knowledge of all these things. Okay, and also suitable soil survey of nearby area, and it is also necessary since huge soil mass is involved in its construction. Okay, so here we can see earth dam. Huge mass of soil is needed. Huge mass of soil is needed to design earth dam. Okay, so here we should have proper knowledge of geotechnical engineering, because this is a earth dam. Okay, so how to control seepage, and because this has very large volume of water. Okay, so it is very important we should have deep knowledge of geotechnical engineering. Next is limitation of geotechnical engineering. As the soil at every location is different, the result and experience from the project cannot be directly applied to other project. Okay, so in every location soil are different, so result also different. So we cannot apply one result to other after getting one result we cannot apply it to other project. Okay, and the strength and behavior of soil depends upon pressure, drainage, climate condition, and many other factors. Okay, so strength and behavior also changes site to site, and it is also varies depth to depth. So it is very critical to find out bearing capacity, because critical means each and every location and every depth we have to find it. Okay, so this is the limitation, one of the limitation of geotechnical engineering. Okay, so properties of soil like density, pressure, shear strength, bearing capacity changes with depth. Okay, so like this, these are also changes depth by depth. Okay, so it is very critical to find, and this is limitation of geotechnical engineering. The next is fundamental use of soil. Fundamental use of soil. In civil engineering, soil has two fundamental uses. First is as a construction material. Second is as a foundation. Okay, in construction material, we use soil as highway embankment, railway embankment, earthen dams, filling in low-lying areas, and as a foundation, building, bridge, highway, tunnel, canal, dam. We use mostly soil. Okay, next is soil formation. Soil formation is a process by which soil is created. Okay, soil formation is the process by which soil is created. The formation of soil happens over a very long period of time. Okay, so to form soil it takes very long time. the soil is formed from the weathering of rocks and minerals. Okay, and weathering is two types. First is physical weathering, second is chemical weathering. In physical weathering, physical weathering involves the breakdown of rocks and soils through direct contact with atmospheric conditions such as heat, water, ice, pressure. Okay, so because of these atmospheric condition, physical weathering occurs, and because of that the soil formed. So this happens without any change of chemical condition. So the soil formed due to physical weathering, will be cohesionless, like sand and gravel. And physical agencies causing mechanical weathering of rocks are so what are the mechanical agencies? Okay, mechanical agencies causing mechanical weathering, those are helps to form soil. So first is daily and seasonal temperature changes, flowing water, glacier and wind, which produce impact and abrasion, action of rock, splitting action of ice, growth of root of plant in rock fissures. Okay, so these are the cause of mechanical weathering. Because of that the soil forms. So next is chemical weathering. Chemical weathering is caused by rainwater reacting with mineral grains in rocks to form new minerals. Okay, to form new minerals like clay and soluble salts. This reaction occurs particularly when the water is slightly acidic. Okay, so chemical weathering form when water is slightly acidic. The decomposition of rock is result of following reactions. Okay, so decomposition of rock happens because of these four reactions. First is oxidation, second is carbonation, third is hydration, fourth is leaching. So what is oxidation? In oxidation, oxygen in air or water reacts with rock. Okay, this reacts with rock. Reacts with rock. By this reaction also cause of chemical weathering. This reaction also cause of chemical weathering. Second is carbonation. Carbonation means carbonation is rainwater forming a acid called carbonic acid. And that carbonic acid is carbonic acid which reacts with mineral of rock. Okay, mineral of rock, that is also cause of chemical weathering. And after that soil will form. And hydration. What is hydration? Water molecules combine chemically. Okay, so water molecules combine chemically with rock mineral. Okay, with rock mineral, that is called hydration. And what is leaching? And leaching means nutrients of rocks and minerals. Minerals are carried out by percolating of water. This is called leaching. This is also one type of reaction, and this is also part of chemical weathering. Because of that soil formed. Okay, so this is all about today's class, and next class we will discuss about properties of soil and properties of soil and three-phase diagram. So see you in the next class. Thank you everyone.